Okay, so this question, first thing first is you need to use a equation called Henderson-Hasselbalch equation, which is written in here in purple. So it's pH is equal to pKa plus log of conjugate base divided by acid concentration, of course. Right. So I'm gonna show you why A right, because wrong, right? Take a look. So in A, you can see that your concentration in A and B are gonna be different, because in A, what you're having is you have 100 milliliter of the acid and you're mixing with 50 milliliter of a base. Now I wrote a concentration of acid as this, but you will notice that it won't be concentration of acid actually, because that would be if we don't add any OH, right? If we're adding water or something. Because we're adding any OH, your concentration of that would be changed by however much molarity of mole of NaOH. So let me go back and step back for a bit. So we want to talk about mole of HA first. So I'm not gonna do the concentration yet. Concentration on one side. First, the seconds, we're gonna do, let's say, oops, I pick up too many, that's okay. So we're gonna show you concentration of amount of acid and amount of base. So let's take a look. So first, let's talk about acid. So in an acid case, HA, we're just gonna call HA. It's gonna to be molarity is 0.1, so we're gonna say 0.1 time mole liter is 0.1 also. 0.1 times 0.1, that's gonna give 0.01 mole. Okay, that's how much HA you're gonna have in the first case. In here, right, the Na, so NaOH is a strong base, so we're just gonna say OH minus. Okay, it's gonna have to be still 0.1, and then it's gonna time 0.005 liter. So that means that's gonna give you a concentration of 0.0, not concentration, sorry, mole of 0.005 mole. And you can see that that means that 0.005 of that will be disappearing. So HA, excuse me, actually left is, I'm going to move it up here because I'm running out of room. HA left here is going to be 0.005 mole, right? 0.005 mole. Because how do I know 0.005 mole? Is because you figure out from here 0.01 minus 0.005, because 0.005 of that is going to neutralize. Okay, so that means that many mole left, which means that divided by total volume is 100 milliliter and 50 milliliter added together, that make 150, so 0.15 liter. Okay, that's gonna give you molarity. Now at the same time, you also get the molarity of A minus. Okay, in this case, if you are careful, you'll see that A minus concentration also gonna be the same thing as HA. Here's the reason why. You have 0.01 mole of HA to start out with. You neutralizes 0.005 mole, right? 0.01 minus 0.005 give you 0.005 HA. But guess what? What happened to 0.005 of the other HA? Well, it's got neutralized, so that means it's left over 0.005 mole, right? Which is still the same thing, divided by 0.15 liter. Now you will see that in this case they happen to be the same, right? They don't have to be the same all the time, but in part A they are the same. So that means if you plug it into here, you're gonna get log of 0. Log of 0 is equal to 1. pH is equal to pKa. So take a look at pKa. pKa is 3.85. pH is 2.4. So still a little bit off. Okay, they're not the same. So the same thing, I'm gonna go back and redo it. In this case, I'm gonna do this guy. Okay, so I want to change it. I want to do this guy bottom here. So see what the number is gonna be different for this. Okay, so we're gonna do this number. So that means my mole is gonna be different. So my mole is still, okay, the first part is the same thing, 0.1, 10.1, 0.1 liter. Take a look at this one. What is it gonna be? Well, 0.1 times 100, so that means that's gonna give you 0.1 times 0.1. That's give you 0.001 mole, right? 0.01 mole. Okay, so what does that mean? That means all of the HA is gonna be neutralized by this. So that means amount of HA left for this case will be 0 mole, right? It is 0 mole. The amount of A minus gonna left is gonna be 0.01 mole. Now notice my volume is also different, 100 milliliter, 100. So that means it's actually 0.2 liter, and this is also 0.2 liter. But you can see that my pH-pK equation is gonna be different. So in this case, you're not really having a buffer solution because you only have a conjugate base, so to speak, which fair enough is can neutralize and what's it called, dissociate, but we're not gonna pick that. We're only gonna pick A. Because it's different, but it's good enough. Okay. Okay. So hope that helped.